Alright, today we're going to talk about absolute value inequalities. We're going to review by looking at the definition of absolute value first. So we looked at this in a previous section, but the definition of the absolute value of x says this. It's either x if x is greater or equal to 0. However, it will be the opposite of x if x is less than 0. Okay, so when we are going to apply this to inequalities, we're going to apply it the same way. It's just that we're going to have inequality symbols instead of an equal symbol. So let's start with looking at example 1, which says this. Solve the absolute value of x is greater than 2. So when we do this, we're going to go ahead and apply our absolute value definition, which says if x is greater or equal to 0, then the absolute value of x is greater than 2 implies that x is greater than 2. Okay, that's part 1 of our answer. However, if x is less than 0, then the absolute value of x is greater than 2 implies that the opposite of x is greater than 2. Okay, so we did the same thing. We did x and then the opposite of x. Okay, so we haven't quite solved for x at this part, so we actually need to go ahead and finish solving for x. So on the one hand, we still have x is greater than 2, but here we have negative x is greater than 2. So when we solve, we need to take care of that negative. So we're going to multiply both sides by negative 1. But when we do that, remember when you multiply an inequality by a negative, the sign flips. So the greater than is going to become less than. Then 2 times negative 1 becomes negative 2. So now you get these two answers. You get x is greater than 2 or x is less than negative 2. So notice that this is an or. If we were to graph this, here it'd be 0. Here's 2, and its x is greater than 2. So we would have an open dot, and we would go to the right. X is less than negative 2. So we'd have an open dot at negative 2, and then we would be going to the left. Okay? So our final answer is x is less than negative 2 or x is greater than 2. So notice that this type of answer is a disjunction, right? It is a disjunction. Okay. So how do we know whether to use a conjunction or a disjunction? How do we decide? Let's think about example 1, and we're going to use our knowledge of absolute values as distances. So think back to your basic definition. Absolute value is the distance between a number, okay? We interpret that the absolute value of x is greater than 2. That's saying that the distance of a number from 0 is more than 2 units. Okay, so from that, it's either that means that it means to be more than 2 or less than negative 2. And so that makes it a disjunction since the number cannot be at both places at once. It can't be greater than 2 and less than negative 2 at the same time. Similarly, let's say we had something like this. Let's say we had the absolute value of x minus 3 is less than or equal to 2. We're saying that the number x minus 3 is at most 2 units from 0. Okay, that's how we interpret it. Which means that if it's at most 2 units from 0, it must be between -2 and 2, which indicates a conjunction. Okay, has to indicate a conjunction. Alright, so there's a theorem that summarizes whether you have a conjunction or a disjunction. So let's look at the theorem. It is the compound inequality theorem. So this theorem is going to tell us, how do we know if it is a conjunction or a disjunction? Okay, so first of all, we're going to just assume that n is a positive real number in every case. Okay, so go ahead and make that your very first statement. Like, this is only working when n is a positive real number. So if that's the case, then there are two things, a conjunction or a disjunction. First of all, the absolute value of x is less than n represents the conjunction x is greater than the opposite of n, and because it's conjunction, x is less than n. So remember, conjunctions you can write as one line. So if you were to write it as one line, you would say this: -n is less than x, which is less than n. Alright, so that's when we have a conjunction, when we have the absolute value of x is less than a positive real number. Let's say we have the absolute value of x is greater than a positive real number. Then we have what's called our disjunction. So remember, the disjunction is the or, because it can't be in two places at once. So when we have the disjunction, we have that x is less than the opposite of n, or, because it's a disjunction, x is greater than n. Okay, so notice the differences between the conjunction and the disjunction, and you can use your theorem to be able to identify, is it a conjunction or a disjunction. Alright, let's do some more examples on solving. We will start with example 2, which says solve the absolute value of 2x minus 7 is greater than 4. Okay, so we're greater than a positive number. So since we're greater than a positive number, that means that we have a disjunction. Okay, so we're greater than a positive number, that means we have a disjunction. I use my theorem that I just had. I have an absolute value greater than a positive number, which means I have a disjunction. So that means either that my x is less than the opposite of the number, or x is greater than that number. Okay, so that means that my 2x minus 7 is less than the opposite of my number. So if my number is 4, the opposite would be -4. Or, because I have a disjunction, my 2x minus 7 is greater than my number, which was 4. So now I solve, right? I have two equations, I'm going to solve them both. Okay, so I'll start with my left-hand side. I'm going to add 7 to both sides. I get 2x is less than 3 Then I divide both sides by 2, and I get x is less than 3 over 2. Or, on the other hand, I'll add 7 to both sides over here, and I have 2x is greater than 11. Divide both sides by 2, and I have x is greater than 11 over 2. So I get these two answers, and it's a disjunction, so I'm not going to combine them. It's just an or statement. Okay, let's try another one like that. Example 3. So I want to solve the absolute value of x is less than negative 3. Okay, so here's my issue. When I do this, I'm saying that I have an absolute value number less than a negative real number. And remember, my compound inequality theorem says that my n has to be a positive real number. So since my number is not a positive real number, that means there is no solution. No solution. Okay? We can also say it is the empty set. All right. However, we have to be careful because we said this was less than, right? However, if we had the absolute value of x is greater than negative 3, then that means that we would have the answer all real numbers. Because if you think about it, no matter what your absolute value is that you're taking, the distance will always be greater than negative 3. Because distance is always positive, which means distance will always be greater than negative 3, which means it doesn't matter what you put in here, it's always going to work. So just be careful. The only time that you get no solution is if you have an absolute value that is less than a negative number. If it's greater than a negative number, then your answer will be all real numbers. All right, let's just do a couple more examples to finish up. I'll do example 4, which says solve negative 4x plus 9 minus 11 is less than 4. Okay, so this is just like when we're solving absolute values. We have to isolate first. So we're going to add 11 to both sides. So now I have the absolute value of negative 4x plus 9 is less than 15. I'm going to apply my compound inequality equality theorem, okay, which since this is my absolute value is less than a real number, it is going to be the conjunction. So let's look again what the conjunction looks like. Conjunction looks like this, right? The opposite of the number is less than x, which is less than n. Okay, so I can write it like that. Okay, so the opposite of the number, so my number is 15, so I'm going to write the opposite, negative 15, is less than x, which is what's inside of my absolute value symbol. So inside my absolute value symbol, I have negative 4x plus 9, which is less than the number, so less than 15. All right, so I start solving for x. Okay, so I start solving for x. So the first thing I want to do is I want to subtract 9. When I subtract 9, I want to make sure I subtract 9 from all three parts. So negative 15 minus 9 becomes negative 24. This becomes negative 4x. And then 15 minus 9 becomes 6. Now I'm going to divide everything by negative 4. Oh, remember what happens when we divide what happens when we divide by a negative? Everything flips. So everything now has to flip. So negative 24 divided by negative 4 becomes positive 6. This becomes x. And then 6 divided by negative 4 is the same as saying negative 3 over 2. Okay? So what I'm going to do now, this is awkward because we read from left to right. So you want to start with your negative 3/2. So I'm just going to rewrite it. So it's going to become negative 3 over 2 is less than x, which is less than 6. So I just wrote it going the opposite way. So here we go. That's our answer for our conjunction. Let's do going the opposite. So instead of solving for an absolute value, let's say we have an absolute value inequality on a graph, and we want the equation. So let's say we have something like this. Here's our graph. Here's 0, here's 1, got negative 1, and we go all the way. I'm going to go ahead and draw on our graph. It's going to be an open dot at negative 5, an open dot at positive 1, positive 1, and it's going to be everything in between. Okay? So I want to write an absolute value. Okay? So remember, these steps are going to be very similar to the steps of when we were doing the equal, right? So when we were writing an equation. Okay? So the step 1 was find your midpoint. Find your midpoint. So again, for right now, I'm just following the steps for when I was trying to find an absolute value equation. And then once I have my absolute value equation, I'll write it as an inequality. So find my midpoint. My midpoint is going to be found by doing a plus b divided by 2. So a plus b divided by 2. So negative 5 plus 1 divided by 2, which becomes negative 4 over 2, which becomes negative 2. So that's my midpoint. So then I'm going to use my definition of distance, right? Which was the distance of a minus b. Okay, so what I'm going to do when I use my definition of my distance, I'm going to find the distance between one endpoint and the midpoint. So find the distance between one endpoint and the midpoint. So my midpoint is here, and my endpoints, I have 2 of them. I can either use negative 5 or I can use 1. Okay, either one. So let's just use negative 5. So I'm finding the distance. So I'm going to use my distance formula. So my distance of one of my endpoints, I'm going to use negative 5. And the midpoint, which was negative 2. So negative 5 minus 2 becomes the absolute value of negative 3, which is 3. So that's my distance. Okay? So what this is saying is that the distance between a number and negative 2, my midpoint, so the distance between a number and negative 2 has to be less than 3, because this is 1, 2, 3, if you think about it, right? So the distance between a number and the midpoint, which was negative 2, has to be less than 3. Has to be less than 3. So I'm going to go ahead and write that. The distance between a number and my midpoint has to be less than 3. So my last step is to just simplify that. X minus negative 2 becomes x plus 2 is less than 3. All right, that is all. Go ahead and try the problems for yourselves.